What I want to talk to you today about is not just large installations, but also real-time installations. And whenever I'm presented with a real-time BI question, which is happening more and more these days, it's you always have to ask what exactly is meant by that term, because it seems that real-time is, depending on who you ask, very differently defined. What I find useful when I do these things is to use the scale like the one below here. So if you look at here, what we're seeing here at the bottom of the screen is basically how the logarithm, the base 10 logarithm of how many nanoseconds something takes. On the very far left, of course, we see CPUs, which tend to run in the gigahertz type range. We see that there's a pretty big jump, almost by an order of magnitude, up to DRAM, which, for those of you who are really crazy about performance optimizations, you will see that that actually matters. It's in that order of magnitude jump that we actually found a lot of the 10x improvements that we're seeing in some of the column store. Another jump up for the NUMA, and then there's this sort of space in the middle between the speed that you get from a NUMA system, if you're talking to a foreign node, and the speed that you get from a modern NAND device. And then up after that, you see a lot of jumps in magnitude, all the way up to the very far right, which is what you could call the typical nightly batch window of a data warehouse. So something that you're taking the system offline in the middle of the night, you're loading some data, and it's hopefully, if everything goes well, ready in the next morning. And the real-time space plays out somewhere between those two extremes. And it's, as you can see, a very wide spectrum. And depending on where you want to live on that spectrum, the methods that you need to do to optimize are very, very different. One of the key things to observe about this spectrum is that whenever you write code, you tend to live in that spectrum that I'm highlighting here. That's where your code works. It works down in the microsecond, nanosecond range. And that's where you're running, that's the work you're doing. And somehow all of that code adds up sometimes to a nightly batch. And that's where your optimization is actually where you can start applying your optimizations down in that space. What I'm going to talk to you today about is I'm going to use an example that we see a lot, which is investment banks. Investment banks, for events that may be obvious to those of you who were around in 2008, are now under a fair amount of legislation to build systems that monitor the way they expose themselves to risks in the markets. But they have always, not just after 2008, but they've always been a very, very interesting place to work with data. They do some really, really cool stuff with the data, and I'm going to describe to you sort of the spectrum that you can look at from these investment banks. So if you look at this is the London Stock Exchange over there on the right. If you really talk about the real time, that's all the way to the left of that axis. What you care about is, let's say you have a server in this little thing here highlighted in the middle. Let's see, there you go. I hope you can see my arrows on the screen too. You might care if you are an algo trader, a person who responds to small fluctuations in the markets based on algorithms that you're running, directly monitoring the stock exchange. You might actually care whether you're placed here instead of somewhere else in London, for example, in the western parts where I'm living. This distance becomes important to you if you live in the real-time space, where you're down in the CPU cycles and where you're counting every single CPU cycle that you're running. And the banks do run these systems, and it's a very lucrative business to get into if you are a skilled C++ coder. I've got a few friends working on that, and it seems to be very, very exciting if you're into that type of geeky stuff. So why do you care about that distance? Well, if we're zooming in on the axis that we saw before, we see some interesting stuff here. Your code lives in this space between the speed of the DRAM and the speed of the fastest disk you can go out and buy nowadays. And in that space where you live, the speed of light is measurable. Light travels only 10 meters in about the time that it takes to execute a piece of code on a large system. So that means the physical distances between the components that you're working on really matters if you're into this type of real-time tuning. And that, if you take data warehousing and BI to the extreme, this is the kind of thing you have to learn about. You have to learn about physics. because there's not going to be any automated algorithm that will fully solve these problems for you. And you are shaving off nanoseconds and microseconds of your code. So the takeaway for that kind of system, that type of real-time system, the most extreme forms, is that you can typically shave off orders of magnitude if you know what you're doing in that space. And that translates to batch windows. If you are doing optimizations that really optimize even the small scale, all of those small scale things you're doing actually add up to making your batch windows shorter, even if you're living on the extreme right side of that scale. So I always find it very useful doing my CAD work to actually think about what the left scale looks like, even though my requirement may not be to live on that left scale. So that is, I think, a key takeaway is you really need to understand what you're running on. And that is essentially what ends up determining what you need to do. Which leads me to my slogan, which is it doesn't take longer to do it right the first time. I find a lot of installations that I visit and coming in typically too late in the game to really change anything. And people have taken all sorts of shortcuts because they believe that it's shorter, that it's faster to create shortcuts in your code and to create dirty hacks because we just need to ship it. And very often you will find that you might save time, but your poor infrastructure team will be struggling. It's very often better just to design the system to scale and to perform right up front. But in order to do that, you need to start thinking about these scales, and you need to have this in the back of your mind. So if we take our zoom lens and click it out a little bit, look at the high-level requirements before we even dig into this. These are the types of questions you need to know about a BI system in order to build one, especially if it's a real-time system. You need to know what's coming in. That's commonly known. Every data warehouse struggles with the data streams, data quality. But of course, you also need to know how fast is it coming in from your sources, because that is going to determine how fast you need to absorb it and eventually how fast you can deliver it to your end user. This means that since you typically tend to transform it, it means that you also have to think about what you need to do with it, because once you start counting the CPU cycles to do joins and group by operators, if that's what you're doing, if you're aggregating data, that's going to cost you, and that will add time to your data. It's one of the reasons that when we design true real-time systems, there really is no other way than Kimball. You can normalize all that you like, but if you really want to be real-time, and you want it to be at a high scale with a lot of users, you're going to have to eliminate joins. Because joins are simply too expensive when you squeeze the max out.